Hello guys, is my screen visible? Okay, so yes, let's start. So today I'm going to explain you about this ensemble techniques in machine learning. Okay, so uh, from the word itself, ensemble. From ensemble word itself, we can understand that the meaning of ensemble is collection of something. Okay. So, but in machine learning, ensemble means the collection of multiple machine learning models or machine learning algorithms, where we are combining them to create a bigger model or a final model which will give us the final prediction. Okay. Uh, so, for to explain you easily, uh, I will give you an example. You must have seen KBC. So when the contestant is in doubt about the correct answer, so what he does is he takes audience poll. Why? Because he has the confidence that the combined knowledge of 100 or 200 people will get him they will give him the correct answer. Then he alone, whatever answer he is giving, but a combined 100 people will give a correct answer. Similarly, second example I can give you that in case of online shopping, before buying a product, you are trying to check reviews of that product. Suppose 20,000 people have bought that product and the rating is 4.5. So you are pretty confident that this product is good. Okay, but in at the same time, suppose there is a product where 100 people or 200 people have given reviews and ratings, and the rating is 4.5, so you will have some doubt in your mind about the quality of this product. But whereas where there is 15,000 people have told have given their wisdom about this product and shared their opinion, so you will be believing that. So this same idea is applied in this ensemble technique. Okay, so let's go directly to the prediction phase. So what happens in this prediction phase? Suppose these are different algorithms, and these algorithms are creating individually. They are creating models. Okay, linear regression, decision tree, random forest, SVM, and so on. Suppose there are five algorithms. Five algorithms I have given data sets, the same data set. I have given to five different algorithms. Okay, so individually, all these algorithms will give a output or give a prediction. In case of a classification problem, suppose there are five models and the output has to be one or zero. Okay, suppose uh, five models between five models, uh, three models have given the output to be one, and two models have given the output to be zero. So the majority count will be taken as the final prediction. Okay, so majority here is one, so the final prediction will be taken as one. Okay, in case of a regression problem, suppose uh, these all these algorithms, all these models will give one output as a number. So we'll collect all those numbers, all the five numbers, and calculate the mean. That mean will be taken as the final prediction. Okay, but there is a very important thing to remember here. Here, variety should be there. Okay, here variety should be there. How? There are three ways. Suppose you are giving same data set to all these five models. That is one. Number two, either you are giving different data sets. Okay, different data, not different data sets. You will be uh, dividing the same data set into groups, and you will be giving uh, to the same algorithm. Okay, or the third method is combining both of the previous two methods, different data sets and different uh, algorithms. Okay, so this variety is very much important actually to give high performance. Then, based on this variety, the ensemble methods are divided into different types. First one is voting, then bagging, then boosting, and stacking. Random forest comes under bagging, and ADA boost, gradient boost, and XG boost comes under boosting. So let's go one by one and know what are the differences between them. Okay, so voting. So likewise, I said uh, these are different models. Okay, these are different models as written here. Diverse predictor. Suppose this is uh, a logistic regressor. This is KNN. This is decision tree, or this is random forest. Okay, so these different models are giving their output one, one, two, one. Okay, they are giving their own individual predictions. Then the majority vote is taken like our election system in our democracy. Majority wins. Similarly, here one is winning here, one is in majority. So the final prediction is one. This happens in voting. Next, in stacking, the same data set is given to four different models. Okay, then four models give their own individual predictions. Then there is also the output, actual output, the actual output of the data, the training data. That actual output and individual predictions of these four models are combined and stacked. Okay, and this whole stack is now will act as a new training set for the second level model, or I can say it is also often called meta model. Okay, suppose it is four different models: logistic regression, KNN, SVM, anything, and here it is random forest. Suppose so, random forest or KNN, anything you can take. So all these predictions and output variable, output column of this training data will be stacked up and given to this random forest. And this random forest will give the final prediction. And there is another point to remember is as a weightage is provided, whichever model works a little bit better than the other, it is provided with a better weightage. Okay. Then comes bagging. Uh, in bagging, what happens is suppose there is 100 observations or 100 okay 100 observations in a data set, and I'm selecting 500 selecting randomly. I'm selecting 500 rows, 500 sample, giving it to the classifier one. Then again, randomly selecting 500 from the this data set and giving to classifier 2. Similarly, giving another 500 from this data set to classifier number 3. Then then the whole these models will do their give their prediction individually, and in case of classifier, the majority output will win, and in case of regression, the mean will be taken. Okay, and the random forest is a special case of this bagging only. uh, so in random forest, the base model is decision tree. Okay, so collection of tree is called a forest. So uh, so in this case, decision tree is the base model of random forest. Okay, then comes boosting. It is a very high performing model, a high performing technique. So in boosting, what happens is, uh, suppose data set is given to this model one. Okay, it is of all these models are also called weak learners or base models. Okay, so first this model one will do its prediction, and while doing prediction, uh, it has done some errors. Okay, so you can see here it will pass all its prediction to the second model, and it will also convey uh, what errors model 1 has done with some weightage. Okay, you can say that it is model 1 is saying to model 2 that look, I have done these mistakes, or I have done these errors, so you better try to decrease these errors, or you focus on these errors. Then model 2 will take all the predictions of model 1 and work on it and give its own predictions. Again, the same process will happen with model 3. Model 2 will send all its predictions to this model 3 with increased weightage to the errors it has done individually. Similarly, the this process will be done, and at the end you will be end up creating a low biased model. Okay, so ADA boost, extreme gradient boost, and gradient boost are three types of boosting techniques. Okay, uh, then why we are using this ensemble learning and how it works better. Okay, so I have attached a picture here, so you can see. Suppose this is a graph of one model, this is a graph of another model, and this is the graph of another model, and you can see these lines here. These are decision boundaries. Okay, and this squares and triangles are different classes, and training data and testing data both are included here. Okay, so these lines are decision boundaries, you can see. So this is the decision boundary of this model. This is a little bit different decision boundary of this model, and this is the decision boundary of model 3. When these three are combined, it is you can see here, it is creating a little bit noise here when it is combined. Okay, then when the majority vote is taken, okay, the majority vote is taken from these three, it is ending up creating this smooth line. This smooth line you can see here. Okay, so now the final prediction can be done very efficiently after this smooth line has been created. This was a case of classification. Let's see what happens in regression. Suppose in regression, these are the best fit lines, and these are four models. This green line, green, red, orange, and blue are four different models. So when you are calculating the mean of all these four models, this dotted line is being created, which is the best line among these four models. Okay, that's why these ensemble learning techniques work really better than the individual models. Okay, then let's know about what are the advantages and disadvantages. Uh, it it really improves the performance because uh, you know that the fact that individual performance will always be little bit less than the combined performance of different models, and it helps in reducing the bias and variance. Okay, so you know that we always try to get a low bias and low variance model, but when we are trying, we are creating a individual models. What we do is we end up creating a model which is low bias but high variance. Problems we face like this. So when we are using ensemble learning, it helps to create a balanced or better optimized model where it has a low bias and low variance. Okay, then robustness. Then disadvantages is, of course, when you know that you are combining different algorithms, different models to create one single bigger model, of course, it will increase the computational complexity. Uh, so that is one disadvantages I can say. So this was it. Any doubts you have, you can ask. Uh, when to use ensemble learning? Actually, see, what I think is actually you can. always use this ensemble learning techniques. You can should always use this, but what I feel is you have to go through this trial and error method. Okay, it is nothing like that. A particular algorithm will work better on this data set, and this other type of algorithm will work better on a different data set. So it is not like that. You have to use, or you have to try a different type of, or I can say every algorithm, three or four or five algorithm you have to try and see what results they give you. Okay, you have to play among them and see what results they give you and select the best one among them. Okay, generally also these ensemble learning methods give you very good results. Especially these became famous due to its very high performance in these Kaggle competitions. XGBoost and boosting techniques and all of those are very useful. Uh, robustness means, suppose if you are making some changes, it doesn't matter how much changes you are making during the training phase or the in the training data set, training data pre-processing, it will not put a huge impact on the results. So that is robustness. Okay, so any other doubt? Okay, so thank you for your time. I'm ending the meeting. Thank you.